Welcome to another episode of Nikita on Drones, the podcast where we explore how drones are shaping the future of our world. I'm your host, Nikita, and today we're diving into a critical topic that's impacting the logistics and transportation industry, the challenges of cargo drones. Cargo drones, specifically designed to carry and deliver goods, have emerged as revolutionary tools poised to transform logistics by offering faster, more efficient, cost effective delivery solutions. However, despite their immense potential, integrating cargo drones into mainstream logistics is not without its obstacles. Today, we'll be exploring the multifaceted challenges that are currently hindering the widespread adoption of cargo drones, focusing on technological, regulatory, economic, societal, and environmental aspects. So let's get started. Let's kick things off by discussing the technological challenges facing the cargo drones. As advanced as these flying machines are, they are still grappling with several technological hurdles that need to be overcome for them to become a mainstream solution in logistics. First and foremost, there is the issue of battery life and payload capacity. Most cargo drones currently rely on lithium ion batteries, which, despite significant advancements, still offer limited flight times, often ranging from 20 to 60 minutes. This limitation significantly reduces the operational range of drones and impacts the efficiency of delivery routes, especially for longer distances. Moreover, the payload capacity of drones is directly tied to their size and battery power. While smaller drones are perfect for carrying lightweight packages, heavier payloads require larger drones equipped with more powerful batteries. However, this increased cost and decreases flight duration, presenting a challenging trade-off between payload capacity and battery efficiency. Balancing these factors to create a viable and efficient cargo drone system remains a significant hurdle for the industry. Another major technological challenge is navigation and collision avoidance. Ensuring safe and reliable navigation is critical, especially when drones are expected to operate in complex urban environments filled with obstacles, such as buildings, trees, and power lines, as well as varying weather conditions. Advanced sensors, GPS, and real time data processing are required to achieve precise navigation and effective collision avoidance. Developing robust algorithms for autonomous flight and obstacle detection is essential but also incredibly challenging. These systems must operate flawlessly to prevent accidents, which could result in damage to goods, property, or worse, injuries to people. The development and refinement of these technologies are crucial for the safe deployment of cargo drones in busy airspaces. Then there is the challenge of communication systems. Reliable communication between the drone and the control center is vital for monitoring flight status, making real time adjustments, and ensuring overall safety. However, maintaining a stable communication link, especially over long distances or in areas with poor network coverage, poses a significant challenge. Interference, signal loss, and cybersecurity threats further complicate the establishment of a dependable communication system. For cargo drones to operate effectively, they need to maintain consistent communication with ground control stations, other drones, and air traffic management systems. Any disruption in communication could lead to operational failure or even accidents, highlighting the importance of developing more resilient and secure communication networks for drone operations. Moving on to regulatory challenges, which are equally daunting. The integration of cargo drones into national and international airspace is a complex regulatory challenge that requires significant changes to existing frameworks. One of the primary regulations hurdles is airspace regulations. Most countries have stringent regulations governing the use of airspace, designed primarily with manned aviation in mind. Adapting these regulations to accommodate unmanned aerial vehicles (UAVs) requires substantial changes. Regulatory bodies must develop new rules and guidelines for drone operations, including flight permissions, altitude restrictions, and no-fly zones. Moreover, harmonizing these regulations across different jurisdictions is crucial to enable seamless cross-border operations for cargo drones. This is particularly important for companies looking to use drones for international deliveries, as inconsistencies in regulations can create significant operational barriers. Another important aspect is certification standards. Establishing industry-wide standards and certification process for cargo drones is essential for ensuring safety and reliability. These standards must cover various aspects including drone design, manufacturing, maintenance, and operational procedures. Developing and enforcing such standards is a lengthy and complex process that involves collaboration between regulatory authorities, manufacturers, and industry stakeholders. Without standardized certification process, it becomes challenging to ensure that all cargo drones meet the necessary safety and performance requirements, which could hinder their widespread adoption. And let's not forget about privacy and security concerns. The widespread use of cargo drones raises significant privacy and security concerns. Drones equipped with cameras and sensors can inadvertently capture sensitive data, leading to potential privacy infringements. Moreover, there's the risk of drones being used for malicious purposes, such as smuggling or espionage. These concerns necessitate the implementation of robust security measures and comprehensive regulatory frameworks that address data protection, surveillance, and the prevention of unauthorized drone activities. Without addressing those privacy and security concerns, gaining public trust and regulatory approval for drone operations will be difficult. Now let's dive into the economic challenges associated with the deployment of cargo drones. While the potential cost saving and efficiency gains from using drones are significant, several economic hurdles need to be addressed. One of the most significant barriers is the cost of implementation. The initial cost of developing, manufacturing, deploying cargo drones, along with establishing the necessary infrastructure for their operations, requires substantial investment. For small and medium sized enterprises, these costs could be particularly prohibitive. Additionally, the maintenance and operational expenses associated with cargo drones, such as battery replacements, repairs, and software updates, add to the overall costs. Ensuring a positive return on investment requires careful planning and efficient utilization of drone fleets, making cost management a crucial factor for business considering drone deliveries. Another economic challenge is scalability. Achieving scalability is crucial for the widespread adoption of cargo drones. While projects and small-scale implementation may demonstrate the potential of drone deliveries, scaling these operations to handle larger volumes of goods across extensive geographic areas is complex. Scalability involves addressing logistical issues such as optimizing delivery routes, managing drone fleets, and integrating drones with existing supply chain systems. Overcoming these challenges is essential to realize the economic benefits of cargo drones on a larger scale and to make drone deliveries a viable option for more businesses. And lastly, there is the issue of market acceptance. Gaining market acceptance for cargo drones is another significant economic hurdle. Businesses and consumers must be convinced of the reliability, safety, and cost effectiveness of drone deliveries. Building trust and demonstrating the value proposition of cargo drones through successful pilot projects and case studies is crucial for driving widespread adoption. Until companies and consumers see clear benefits such as reduced delivery times, lower costs, or improved service, the transition to drone based logistics will remain slow. Beyond technological, regulatory, and economic hurdles, cargo drones also face societal challenges that can impact their integration into mainstream logistics. One of the most significant challenges is public perception and acceptance. Public perception plays a vital role in the successful integration of cargo drones. Concerns about safety, noise pollution, and the potential disruption of daily life can hinder the acceptance of drone deliveries. People may worry about drones flying over their homes or neighborhoods, the noise they generate, or the possibility of accidents. Educating the public about the benefits of cargo drones, such as reduced delivery times, environmental sustainability, and improved access to remote areas, is essential for gaining their support. Transparent communication and community engagement are key to building trust and acceptance among the public. Another important societal issue is the impact on employment. The widespread adoption of cargo drones can have significant implications for employment in the logistics sector. Traditional delivery jobs, such as those of truck drivers and courier personnel, could be at risk as drone deliveries become more prevalent. Addressing these potential impacts by training workers and creating new job opportunities within the drone industry is crucial for mitigating societal resistance. It's important to ensure that the transition to drone logistics does not lead to widespread job losses, but instead opens up new opportunities for employment in areas like drone operation, maintenance, and management. And finally, there's the challenge of infrastructure development. The successful deployment of cargo drones requires the development of dedicated infrastructure such as drone ports, charging stations, and maintenance facilities. Integrating this infrastructure into urban environment and existing logistics network poses significant challenges. Coordinated efforts between government, urban planners, and industry stakeholders are necessary to develop the required infrastructure and ensure seamless drone operations. Without the appropriate infrastructure, the scalability and efficiency of cargo drone operations could be severely limited. Last but not least, let's talk about the environmental challenges associated with cargo drones. While drones are often viewed as an environmentally friendly alternative to traditional delivery methods, their energy consumption and sustainability are important considerations. Energy consumption and sustainability are critical factors. The production and disposal of batteries, along with the energy required for charging, can have environmental impacts. Although drones produce zero emissions at the point of use, the broad life cycle of drone batteries from manufacturing to disposal can contribute to pollution and waste. Developing more efficient battery technologies, exploring alternative energy sources, and implementing recycling programs for drone components are essential steps towards minimizing the environmental footprint of cargo drones. Innovations in battery technology such as solid state batteries or hydrogen fuel cells could help reduce the environmental impact by providing longer lasting and more sustainable power sources. Another environmental challenge is noise pollution. The noise generated by drone propellers can be disruptive, particularly in densely populated urban areas. This noise pollution could lead to public opposition and hinder the adoption of drone technology. Designing quieter drones and establishing noise regulations for drone operations are necessary to mitigate this issue and ensure minimal disruption to communities. Researchers are already exploring ways to design quieter drones, such as optimizing propeller shapes and developing dampening, dampening materials. Addressing noise pollution is critical for ensuring that drones coexist peacefully with people in urban environments. In conclusion, while cargo drones hold immense potential to transform the logistics industry by offering faster, more efficient, cost effective delivery solutions, their widespread adoption is hindered by a range of challenges spanning technological, regulatory, economic, societal, and environmental domains. Addressing these challenges requires coordinated efforts from governments, industry stakeholders, and regulatory authorities. Technological advancements in battery life navigation systems and communication networks are crucial for overcoming the operational limitations of cargo drones. Regulatory frameworks must evolve to accommodate the unique requirements of drone operations, ensuring safety, security, and privacy. Economic viability depends on reducing implementation costs, achieving scalability, and gaining market acceptance. Societal challenges, including public perception, employment impacts, and infrastructure development, must be addressed through education, training programs, and collaborative planning. Finally, environmental considerations such as energy consumption and noise pollution require innovative solutions to minimize the ecological impact of cargo drones. As these challenges are progressively addressed, cargo drones have the potential to revolutionize logistics, providing a glimpse into the future of transportation and delivery. By navigating these obstacles, the logistics industry can unlock the full potential of cargo drones, paving the way for a more efficient, sustainable, and connected world. Thanks for tuning in to this episode of Nikita on Drones. If you found today's discussion insightful, don't forget to subscribe to the podcast and leave a review. Until next time, stay informed or keep thinking about how drones are transforming the world around us.